that are very important to sketch the graph of rational function. So our title is steps that we use or that we should have to follow to draw or to sketch the graph of rational function. Let me write the title. So this is the title of our today video, or today we are going to see steps used to scale the graph of rational function. We have 5 or 6 steps that enables us to sketch or to draw the graph of the function. The first step is step 1, or the first step is finding the domain. Find the domain of the function. So the first step that should have to go through in drawing the graph of rational function is finding the domain. If the rational function is of the form, if the function is given in the form of f of x is equal to n of x over d of x. So how can we find the domain? The domain of rational function is the set of all real numbers except those numbers that makes the denominator 0. So set of all real domain is equal to all real number without numbers that make the denominator d of x 0. So exclude from real numbers that makes the denominator 0, so that it is taken as a domain. I will show you this by taking certain examples in the next video. So the first one is just finding the domain. The second step is just finding intercepts. Find the x-intercept. And y-intercept. We are going to find the x-intercept and the y-intercept. As you know, what I mean by x-intercept? X-intercept is the point at which the graph crosses or touches the x-axis. So we are going to find the x-intercept by just making y is equal to 0. Let y is equal to 0, and after letting y to 0, the number that you come across is said to be the x-intercept. So for finding x-intercept, just let y is equal to 0. Y is equal to 0, then obtain certain values for x, and just put those points in order to perform. Therefore, that is the x-intercept. The other one is the y-intercept. So when we say y-intercept is the point at which the graph crosses or touches the y-axis, as we mentioned for the x-axis, or it has the same concept with the x-intercept. Therefore, y-intercept is the point at which the graph may touch or cross the y-axis. At this point, as you may know, or as you know, at a point at which the graph touches the y-axis, or the point at which The graph crosses the y-axis. At that point, the value of x is 0. Therefore, to find the y-intercept of the graph, so you should have to let x is equal to 0. And then obtain certain values for y. Then put in an order per form, therefore, that is the y-intercept. This is the second step that you should have to do when we are asked to scale the graph of the function. So what else? We have the third step also. Let me continue. The third step is, step 3 is the asymptotes. You should have to determine the asymptotes. Asymptotes. So as I said previously, asymptote is a line to which the graph may approach as far as possible, but never cross or touch. Those lines are the graph of asymptote, or asymptote by itself is a straight line. It's a straight line, but it cannot be a convex or a parabola. It's always a straight line. So a straight line, asymptote is a straight line. It is a straight line. So since asymptote is straight line, so asymptote can be a vertical straight line or a horizontal straight line, or maybe an inclined straight line. So if it is a horizontal straight line, it is assumed as a vertical asymptote. And if it is a horizontal straight line, it is a horizontal asymptote. While if it is a sort of inclined line, so that inclined asymptote is considered as an oblique asymptote. So we have mentioned how to determine whether a rational function we have a vertical asymptote, horizontal asymptote, oblique asymptote in our previous class. Now, you should have to remember those and find, recall those methods that we were using in determining the horizontal asymptote, vertical asymptote, and the vertical asymptote. Therefore, here you should have to find the horizontal asymptote. And the horizontal asymptote is just obtained. It is obtained by comparing, obtained by comparing, the degree of what? Degree of n of x and that of d of x. So you should have to compare, in finding horizontal asymptote, you should have to compare the degree of n of x and the degree of d of x, as I previously said. So if the degree of n of x is less than the degree of d of x, then x is y is equal to 0, or x-axis is considered as a horizontal asymptote. If they are of the same degree, then y is equal to the ratio of the leading coefficient of n of x to that of d of x is considered as a horizontal asymptote. So this is the criteria. Second is the vertical asymptote. So to find the vertical asymptote of a rational function, just let d of x to 0 and obtain certain number. Suppose d of x is a sort of quadratic equation, and then you get by solving d of x equals 0, suppose you get x is equal to n, x is equal to b. So to take this one as a vertical asymptote, those one as a vertical asymptote, you should have to insert this to the numerator and to the numerator. So if n of x, n of a is different from 0, while d of a is 0, and n of b is different from 0, while d of b is 0, therefore from this, the lines x is equal to a and x is equal to b are our vertical asymptotes. The final one is the oblique asymptote. Oblique asymptote. So oblique asymptote is going to be obtained just by comparing the degree of numerator to the degree of the denominator. As I said previously, if the degree of the numerator is greater than one more greater than the degree of the denominator. Suppose if the degree of the numerator is n plus 1, and if the degree of the denominator is n, if the degree of the numerator is denominator is n, the degree of the numerator must be n plus 1. So that such type of rational function will have an oblique asymptote. And that oblique asymptote is given in the form of y is equal to mx plus b. Therefore, this expression is going to be obtained by dividing n of x to d of x by long-term division. So when you are asked to draw the graph of rational function, you should have the step that you should have to go through is just using finding the asymptotes. So we have other steps left. The fourth step is step 4. Step 4 is finding the zeros. You should have to find the zeros. Find the zeros. The zeros of the function. So this is important. This is the fourth important point that you should have to search or that you should have to seek when you are asked to draw the graph of rational function. So how can we find the zeros of rational function? The zeros of rational function can be found in this way. Suppose f of x is equal to n of x over d of x, where n of x and d of x are polynomial expression, is a rational function. So how can we find the zero? The zero is going to be obtained by letting f of x to 0. So let f of x to 0. Instead, you should have to make n of x is equal to f of x is equal to 0. 0 is equal to n of x over d of x. So this leads us to what we call n of x is equal to 0. So from letting f of x to 0, you are going to get this one. And this is said to be the zeros of rational function. From this, you are going to obtain the zeros. And these are the necessary steps that you should have to follow in sketching the graph of rational function. This is all about steps that you should have to use in sketching the graph of rational function. And I wanted to say thank you very much, and do not forget subscribing. Thank you very much.